All right, so in this lesson we will write the equation. So write the equation of an exponential function. So I'll circle that, of an exponential function. We are going to be given its graph or table of solutions. So we're going to be given a bunch of x, y's, and then we'll need to figure out the equation of the exponential function. Remember, exponential functions will either go up really fast or go down very quickly. So David has money. The amount changes exponentially over time, so we're given months. So we care about the money. So let me do that. Let's say we care about the money. So we'll put the money here, right? Well, I guess we'll put D for dollars. And that will change depending on the number of months. Now remember that exponential will mean that we are multiplying. So we don't have the y-intercept. We don't have 0 something, but we have this and then this and then this, right? So if we don't know what we're multiplying by, then we have to divide. Let's do a 44.1. Well, I guess I should put it to the side. So we're going to multiply by 44.1 divided by 42. So 44.1 divided by 42. Let's try that. Let's see. 44.1 divided by 42. 1.05. 1.05. Now let's check and see if this is the same. So 44.1 times 1.05. 44.1 times 1.05 equals 46.305. 46, okay, cool. So it's the same. It should be, but it's always best to check to make sure nothing's weird. So in our equation, if we're going to write it, we have to, let's use this purple. We're going to put it in this form. We're going to do f of x equals a b to the power of x. So this will be our initial amount. I guess I can write that a little bit better. Our initial or beginning amount. And this b will be our multiplier. Multiplier. Okay, well, we're going to multiply by. So we know, well, we got to know what this is in the beginning. So we need to get back to this 0, right? We need to get back to this 0. So instead of multiplying, we will actually need to divide by, well, maybe I'll put that in red so you can tell that it's different, and then that's what we're using it for. Divide by 1.05. So 42 divided by 1.05. 42 divided by 1.05 equals 40. 40. Okay, so let's make sure that makes sense. Okay, this is increasing. Let's take 40 and multiply by 1.05. 40 times 1.05 gives me the 42, which is next. Yeah, okay. So we know that the dollars are a function of the, maybe I should do it like that, are a function of the number of months that pass. And that will equal, we start off with the initial amount is 40. And we multiply we multiply by 1.05 times, well, we multiply by 1.05 over and over and over again, but we multiply it by the number of months. So to the power of months. And we can also write this as, I'll just keep it in orange. Dollars are a function of money. Starts off at 40. Remember, we always want to start off with this 1. We have 100%, and we add 0.05 to the power of months. You'll see both of these on that test, so I just want you to be familiar with both. Okay, so let's do this explanation. So the number of dollars, you could also say the amount of money, is increasing. We're increasing as we go further down. We're increasing. Well, I guess I should do it in orange. It's increasing by, well, let's see. You see this 0.05? Well, I'll put it right here. This 0.05, if we move it back to the right, that means we get 5%. So the number of dollars is increasing by 5%. Every 1 month, every month. And you can see that we are increasing 40, 42, 44, 46. So this is called exponential growth. It says, what kind of exponential relationship is this? It's growth right here. Well, let's get orange. Okay, so let's do it again. The population of Fort Worth in thousands is decreasing. You can see it's going down very quickly. So let's do it. We're talking about population. Well, let's make a table first. Well, I think I can make it a little better. Okay. We'll do it one more time just to make sure. Okay, I guess. So the population in thousands depends on, oh, it doesn't tell us. So we'll just say a time. We'll just say sign. We'll just put population here in thousands. We'll do it by years. By years. If it doesn't tell you, just make it work. Okay, and we don't see the 0 year, so I need that. So I'm going to leave that here, but I don't know what it is, right? And then we have 132. And then 216. Well, I'm going to go 1 and then 2 and then 3 like that. And then I'm going to put the 32, 16, 8. Oh, you can see it looks like it's dividing by 2, right? Well, let's check it out. So let's figure out what we're multiplying by. In order to figure out what we're multiplying by, we have to divide backwards. So 16 divided by 32. 16 divided by 32. Well, that's just half, but let me just show you. 16 divided by 32 is 0.5. So that means 16 times 0.5 is 8. Let's try it. 16 times 0.5 is 8. Okay, cool. And then let's go backwards because we need to know this initial amount. So instead of multiplying by 0.05, we divide by 0.5. And then we get 32 divided by 0.5 is 64. And we can tell that's true because like 64 divided by 2 divided by 2 divided by 2 or times 2 times 2 times 2, right? Going backwards. Let's go ahead and write our equation. Remember, it's in the form of f of x equals a b to the power of x. Remember that b, well, I'll show you. So we're talking about the population. And population is a function of my number of years. Oh, I made that red. Oh, I know why. That was supposed to be green. Population is a function of years. where the population equals, well, it starts with 64. Oops. Starts with 64. I guess 1,000, right? We're talking about thousands. 64,000, and we're going to keep multiplying. We're going to keep multiplying by 0.5 over and over again. Like the number of times we're going to multiply by 0.05 depends on the number of years that we have. Like if it's like 3 years, then we're going to put 3 here, right? If it's 4 years, we'll put 4 years. 5 years, we'll put 5 right here. This will be the number of years. And let's see, we can do this also. So I'm going to keep this in orange like I did last time. So population in terms of years equals 64 times something to the power of years. Now, I need to figure out how to get from 1 to 0.5. So if you don't know, this is 1 minus 0.5. But if you don't know it, like, let me show you something. So you can always use subtraction. I'll put right here, subtraction. And let's say we do it backwards again. 0.5 minus 1. 0.5 minus 1. You see how we get negative 0.5? That means minus 0.5. So I'm going to write it over here. We did 0.5 minus 1 equals negative 0.5. Okay, and we can see that that's how we get from 1 to 0.5. We subtracted 0.5. So we start at 1, and we subtracted 0.5. I'll make a little bit more room. All right, so we're talking about the population. So the population in thousands, that's what it says, right? Yeah, in thousands, is, we're not increasing. You can tell that we're decreasing. Is decreasing. Where's my orange? Okay, it's decreasing by, okay, so we have 0.05. 0.5, 0.5, not 0.05. That was over here. So 0.5. We move it twice. 50%. So the population in thousands is decreasing by 50% every year. And since we are decreasing, it says what kind of exponential relationship is this? Since it's decreasing, this isn't growth, this is decay. Like, you know, like things decay over time. Decay. So this will be increase, and this will be decrease. I like to write that a little bit better. What did I write? Decrease. All right, cool. And that's it. Thank you.